So we find our critical points when the derivative is 0 or undefined. So when I take the derivative, taking the derivative of an integral, it's just going to undo each other. So I'm just going to get x cubed minus 3x. And critical points happen when equals 0, so I'll just have x times x squared minus 3. And this equals 0 when x is 0 or plus or minus root 3. So those are my critical points. And if I wanted to, later on I'm going to have to graph. So if I put negative root 3, 0, and root 3 on my sine line and plug in values of x in each of the intervals, if I plug in something way positive, a positive times a positive will be a positive, and then it should alternate. Sweet. So those are my critical points. Kind of got a shape of my graph there. If I wanted to talk about concavity, that comes from the second derivative. So the second derivative is going to be just the derivative of the first, so that's 3x squared minus 3. It's going to change concavity when the second derivative is 0, so that's going to happen when x is plus or minus 1. And if I put that on the same graph, a negative 1 here and a positive 1 there, if I plug in anything bigger than 1 into my second derivative, that'll be positive. So I'm concave up beyond 1. If I plug in anything between negative 1 and 1, like a 0, 0 squared minus 1 is negative 1, so I'm concave down between there and there. Plug in something over here, I'll be concave up again. So that is the basic shape of my graph. And when I talk about concavity, they're going to want to see it's concave up from negative infinity to negative root 3 union, nope, not root 3, negative 1, union 1 to infinity, and concave down between negative 1